Okay, this is the third video where I'm going to show you what to do if you're starting with pH or pOH and trying to go back and calculate concentrations. So let's do E. I have a pH of 7.4, which is the pH of human blood. So let's go to pOH first. So to do that, I'm going to say 14 minus 7.4, and that will give us 6.8. Okay, so now what I want to do is I want to get hydrogen ion concentration. So to get the hydrogen ion concentration, I'm going to do 10 to the negative pH. It will not work if you do not do negative, so make sure that you're going to do that. And then what you want to do in your calculator is you want to hit the second button, and then you want to hit the log button, log to the base 10. Then you're going to hit a negative and 7.4. And when I do that, I get 3.98107 times 10 to the negative 8th. Okay, this is a concentration, so we want to be sure to include units. And then we need to think about significant figures. So our pH had one number after the decimal. So what that means is that we need one significant figure. So that is going to round to 4. So our answer is actually going to be 4 times 10 to the negative 8th molar. Okay, now what we want to do is we need to get hydroxide ion concentration. So I could use the ion product for water, or because I have my pOH, I can say hydroxide ion concentration is 10 to the negative 6.8. So second and log to the negative 6.8, and I get 1.58 times 10 to the negative 7th. Molar. What I need to do here is I've got one number after the decimal, so my answer in terms of sig figs needs to have one number, so that would round to 2 times 10 to the negative 7th molar, and that's my answer. All right, so now we want to look at how to do F. Gastric juice, the pH of gastric juice is 12.7. So from that, let's go ahead and calculate hydroxide ion concentration. So that will be 10 to the negative 12.7. So you're doing second log to the negative 12.7. If you're not sure how to do that in your calculator, just ask Dr. Quick or myself. We've got one number after the decimal, so that means we want one sig fig. And I got 1.995, so let's make that 2 times 10 to the negative 13th molar. So that's our hydroxide ion concentration. So we've got pOH, we've got hydroxide ion concentration. Let's calculate hydrogen ion concentration. To do that, I'm going to use ion product Kw of water, which is 1 times 10 to the negative 14th. I'm dividing that by my hydroxide ion concentration, 2 times 10 to the negative 13th. Remember, that equation is Kw equals hydrogen ion concentration times hydroxide ion concentration. And the value for Kw is 1 times 10 to the negative 14th. So just writing it differently so you can see it differently. Okay, so when I divide, I got, whoops, I lost my pen. I got 0.05. Okay, I need to check sig figs. I have one sig fig here. I need one sig fig with my answer. It is a concentration, so I need units for that. Okay, so now I've got hydrogen ion concentration. Now I want to calculate pH. pH is negative log of my hydrogen ion concentration. So negative log of that number of 0.05 is 1.30. I have 1 sig fig here, so I need one number after the decimal. If I look at that pH, it is acidic, which would make sense since it is stomach acid. I've got a couple other example problems. I think I'm going to include this one in this video because this would be another way you might see it worded. And then the problem after this I'm going to do in a separate video because it's kind of long. So we formed a solution by dissolving an antacid tablet in that, and that solution has a pH of 9.18. So that would be basic, which would make sense because we've got an antacid tablet. Wants us to calculate the hydrogen ion concentration. So to do that, I want to use my 10 to the negative pH equation. So 10 to the negative 9.18. So second log to the negative 9.18. And I get 6.607 times 10 to the negative 10th. Need to check sig figs. I have 2 numbers after the decimal, so that tells us 2 sig figs. So our answer will be 6.6 times 10 to the negative 10th molar.